Jason Stowe. I'm from Cycle Computing, and we essentially, since 2007, have been running high throughput and high performance workloads inside of cloud resources, most notably Amazon Web Services. We have a pretty large customer base, including majority of the 8 largest pharma, 2 of the 3 largest banks, 3 of the 5 largest insurance, and 2 of the 3 largest next-gen sequencing companies that are using our software to run HPC workloads on internal and external compute. We call this HPC orchestration, and I guess our fundamental belief is that utility access to high-performance computing is going to be the single largest accelerator of human invention over the next few decades. Yeah, so our software does HPC orchestration, so we take care of all the data distribution, the movement of the workloads, the air handling of the cloud infrastructure. We make it very easy for users to run internal engineering, life sciences, finance, and insurance applications on external infrastructure that also run on their internal infrastructure. Some of the examples of this are, for example, a 10,000 server cluster that we created in February of this past year. We had a Big 10 pharma that was looking to run about 340,000 hours of computation. So this is about 39 and a half years of computing that needed to be done in a compressed time frame against a cancer target. So they were essentially trying to dock molecules against proteins affiliated with cancer to figure out if this was a good fit or not. It's much like a locking key problem, except instead of having the tens of keys that you have on your keychain in your pocket, they have tens of millions of keys that they're testing. So this 340,000 hours, rather than buying 10,000 servers, which IDC estimated would cost $44 million and use approximately 14,400 square feet of data center space, they were instead able to create this cluster in about an hour and a half to 2 hours, run the entire workload on it during that time and the remaining 9 hours. So they finished basically 40 years of science in 11 hours, and the total cost to them was $4,372 in infrastructure. So this is a pretty significant advantage over having to build that out, wait 9 to 12 months for the server to be, the cluster to be available. They can now do this much more interactively and as they need to. Cloud right now is not going to replace capability machines. We think that a lot of the large supercomputing centers with fast interconnect, there's a definite reason that those are there, and this isn't to address those use cases, the large hero runs. This is more for your day-to-day science, like processing the data that comes off of scientific instruments, like genome data from the next-gen sequencing. It also handles a lot of financial services and smaller CAD/CAM and CAE workloads, so things that fit well on tens of servers. And essentially what we've seen is a very large amount of high throughput workloads at large scale and these MPI workloads that are many small MPI jobs being run in these environments. And you do get better dollars per unit science in most cases, as well as a better essentially turnaround time for the workload as a whole. And in fact, one of the things that we recommend for customers is that as they're benchmarking applications, that they consider more than just the absolute performance of an individual task within their workload, but because cloud can go very wide, what about the runtime of their workload as a whole, and essentially the dollar per unit science across that entire workload? Those are the metrics that we see becoming increasingly relevant, like with folks like J&J and Novartis and Life Technologies, Pacific Life Insurance, and Hartford Life Insurance, who all spoke at Amazon reInvent last year on their use of our software with cloud. So in the future, you and I had talked a little bit earlier about where we think things are going. So I continue to see most of the high throughput workloads moving into cloud computing spaces, and both small MPI oriented and batch oriented. But we do also think that there's going to be a lot of hybrid models happening. So we think that there's a pretty large need for, on the large scale, having an internal cluster bursting to external capacity, whether that's on something like an internal cloud, an internal virtualized environment, or a public cloud like Amazon Web Services. But the second thing is we see a lot of cloud-only deployments where these class of questions could only be run on the kind of capacity like 10,000 servers for 11 hours that would be really impractical to deploy otherwise. So that's essentially kind of the two trends we see there. And I guess the last one is interactive supercomputing, so interactive use of large core counts will probably get more common. You can create a 10,000 server infrastructure on AWS nowadays for as little as about 80 euros an hour. So that kind of compression, the fact that I can borrow that for a very brief period of time and give it to a high-value researcher, high-value engineer, high-value finance person can tremendously increase the productivity of our best minds at really low-cost price points. So this is another area that we think is going to be very interesting kind of moving forward. Well, thank you, Ed.
Okay, welcome.